Up till now, we've been using the Unreal Engine's default global illumination and reflection system to work around in the scene. As you know, we have placed these high quality assets, we painted some foliage, we brought in some Minerva assets, we also did some lighting setups as well. Everything that we've worked on so far, we've been using the Unreal Engine's default global illumination and reflection system, which is Lumen. You can see that with Lumen, we have some really good looking shadows, we have some really good looking global illumination, everything looks great, and our shot looks good as well, as you can see. But the problem with Lumen is that it is just not as much realistic as path tracing. Now, I do understand that with each update, Lumen gets better and better, but at the time of filming this video, Lumen just isn't there yet, and we still need path tracing for our renders. So if you're looking for something very film-like visuals or very cinematic looking, crisp looking results for your shot, you're gonna need path tracing for that, okay? So what actually is path tracing and how we can set that up for our scene? Path tracing is actually a different kind of global illumination method, and unlike Lumen, in 5.3, path tracing is not available in real time. In Lumen, you can see that we can freely navigate around in our scene without any sort of way to calculate the bounce lighting and whatnot, but that is not the case for path tracing. If we move around in our scene, in path tracing, it is going to take some time to calculate all that bounce lighting, the direct lighting, the indirect lighting, all that kind of stuff. And then after some time, it's going to give us some sort of results. Okay? So that is the drawback of using path tracing, that it is not available in real time as of Unreal Engine 5.3, but path tracing is the best possible global illumination system in Unreal Engine. So how can we enable that for our project and then navigate in the scene by using path tracing global illumination? For that, you're going to have to go into Edit, Project Settings, and search for Ray Tracing. And make sure that hardware ray tracing is enabled, and also make sure that path tracing is enabled. One more thing that you need to set up in here is that if I search for default RHI, you need to make sure that this is set to DirectX 12, okay? So I'm just going to close this thing, and in order to view the scene in path tracing, I'm going to go in here and simply just select path tracing. And as you can see, now we have this very noisy sort of image in here, and pretty much like the cycles render engine in Blender, you can see that it takes some time to get rid of all that noise and clean up the image, okay? So this is how you can enable path tracing for your scene or for your project. And you can see that we also have this progress bar as well, which indicates how much number of samples it has calculated so far. Let's now discuss a few path tracing settings, and then you'll get to know more about this thing. So before that, what I'm going to do in here is to, I'm going to adjust the outliner. Let's go back to lit mode, and if I split this window and, hide the night scene and enable the environment lights, you can see that the exposure isn't just right at the moment for this shot. Of course, we can go into the camera and adjust the exposure, but if we then switch back to the night scene, then we're going to have to adjust the exposure again, okay? Which is too much of a hassle. So what we can do in here is to have a duplicate post-process volume for the day scene, and then simply we'll just disable the exposure from the camera settings, okay? Let me show you what I mean. I'm going to open up this night scene folder and duplicate the post-process volume. I'm going to drag this post-process volume into the environment lights folder, which is the folder for our day scene. And I'm going to set the exposure inside this post-process volume. For the day scene, we set up the exposure of 1. So I'm just going to type that in here. Now I'm just going to hide the environment lights, the day scene folder, and just go into the camera, select the camera, and uncheck these two boxes so that we can control the exposure in the post-process volume instead of the camera, okay? Now it is not going to override whatever we have in the post-process volume. So I'm just going to close this folder, and if I now hide the night scene and unhide the day scene, you can now see that we don't have to adjust the exposure in here. And if I then switch to the night scene, you can see that now we no longer have to go into the camera settings and adjust the exposure each time we switch between day and night scenes, okay? So now what I'm going to do is I'm going to have a different lighting setup for path tracing. So I'm just going to duplicate this night scene folder. I'm going to press my right mouse button, open up this menu, and select duplicate hierarchy. Okay, it's going to duplicate the entire folder and everything that we have inside of it. I'm going to hide this one and select this one and rename this as night scene, bracket open, path tracing, bracket close. Okay. So now we have a different lighting setup for path tracing. I'm going to now go into the post-process volume and let me just enlarge this window. If I'll move this thing here and search for path tracing, you can now see that we have these settings in here that we can tweak for the path tracing global illumination. Okay. So I'm just going to uncheck this box for now so that I can explain all these settings. Then once we are done with these settings, we'll discuss this one as well. Let me just move somewhere around here and maybe here. Yeah. Okay. So the first setting that we have in here is the maximum light bounces. Before we discuss the maximum light bounces, I want to show you what actually is a light bounce. For that, I'm just going to demonstrate this by copying this character. I'm going to duplicate this character, bring it just about there. And I'm going to also bring in a plane. And I'm going to move this thing up on Z, rotate it like so. You don't have to follow along. This is just for the sake of demonstration. I'm going to scale it up, move it up on Z axis and bring it maybe just about there. I'm going to move this thing like so. There we go. So what actually is a light bounce? Whenever you have some sort of light in your scene, whether it's a point light, a rectangular light, or in our case, we have an HDRI and the direction light as well. What happens is the light comes in from the atmosphere, it strikes the surface of the assets and then bounce off that surface to reach the other assets, for example, this character, and then bounce off from that character and then continue to do so until it terminates or maybe leave the scene. So this is what is called as light bouncing, okay? Light comes in from the atmosphere, it strikes with the surface of the assets, and then it bounces off the surface of those assets, strikes with some other surfaces, and then bounces off those surfaces as well until it eventually terminates or leaves the system, okay? So let me select the post-process volume. And as you can see in here, we have the maximum number of light bounces setting. So by controlling this value or slider, we can actually control the number of times the light will bounce off of different surfaces before it actually terminates. Let's say that if I set the maximum bounce of 1 in here, let me switch to path tracing. Okay. And right now you can see that the maximum bounce is 1, which means that light will now only bounce off of once from a surface before it eventually terminates. In this particular example, light is going to come in from the atmosphere. It is going to strike with the surface. It's going to then bounce off of the surface and then it's going to automatically terminate itself. But if I set this to, let's say 2, now the light is going to come in from the atmosphere. It's going to strike with the surface, bounce off of the surface, and then also strike with this character, then bounce off of this character, and then it will terminate itself. So by using this slider, we can actually control how many times the light will bounce off of different surfaces before it eventually terminates. Okay. So one thing that I like to mention in here is that this setting comes in really handy for the interiors because the interiors are enclosed surfaces and light continues to bounce off of different objects, different surfaces before it actually terminates itself. However, that is not the case for exteriors because exteriors are open worlds. Light can simply bounce off a surface once and just leave the entire system. So for the most part, I think the maximum number of bounces can be somewhere between 3 or 4 or 5. Or if you really want to overkill this thing, you can increase this to 6. Please don't go over 6 or 7 or at very best 8 because above 8, you're not going to see any sort of difference in your scene. You're going to reach a point of diminishing returns. So anything above 7 or 8 is completely useless for exteriors, okay? That is because in exteriors, light can completely just bounce off of different surfaces once or twice or maybe even thrice and then completely just leave the system. So at very best, if you have some assets like these where light can bounce off of different surfaces of these assets, you can increase this up to 6. But for the most part, I think anything above 4 or 5 is a very good number, okay? So next up in here, we have samples per pixel. Now, samples per pixel is a very important setting in here because that is what cleans up all the noise that you have in your scene, okay? If I bring the number of samples down to 10, you can see that we have a lot of noise in the scene because Unreal Engine completes the number of samples and leave the image where it is. So that is why you need a high number in here. For example, if I set this to 100, you can see that now we have a much cleaner image, but we still have a lot of noise in the scene. So let's see what happens if we increase this to 500. Now we can see that we have a lot more cleaner results in here. So this is a very highly arbitrary setting, and you're going to have to test this depending on the scene, depending on the shot that you're working on. Okay. For example, if I set this to 500, you can see that we have pretty less noise in here. But if you notice in these darker areas, we still have a lot of noise. Okay. So maybe let's increase this up to, I don't know, 1048, which is the default value. Let's see what happens at the default value. As you can see that we're not even halfway there, but our image looks a lot cleaner already. So this is what we get at the default value. You can still see that we have some sort of noise in here. So maybe I should crank this up to, let's say, 4096 to have a very clean image, but only set this number if you have a very high-end GPU. For the most part, I think for this scene, I think we can get away with the default value. Now, one more thing that I like to mention in here is that sometimes people ask me that why do we set the samples per pixel to the multiple of 2? For example, 2048, 4096, 512, 256, 128, 64, 32, and so on. Is it necessary to set the samples per pixel to a multiple of 2? If yes, then why? The reason for that is actually the architecture of the GPU. The architecture of the GPUs are designed in such a way that they are optimized in a way where they can work efficiently if you set the number of samples to a multiple of 2. I personally haven't tested this, but at least that is what my thinking is, and I generally just like to keep this at a multiple of 2. So next up in here, we have a maximum path exposure. To demonstrate this, I'm going to move somewhere around here. And maybe just about there. And let's give it some time to clean up all the noise. Okay, so now it has rendered all the samples per pixel that we have in here. And as you can see, even after calculating all those samples, we still have some sort of noise in here. You can see we have this very tiny pixelated sort of bright spots in here. We have one in here, and we have some teeny tiny bright spots. And also up here, we have this cluster of bright spots as well. These are actually what's called as fireflies inside Unreal Engine, and this can happen when you have a very shiny sort of metallic surface in your scene. Okay. So in order to get rid of these fireflies, what you can do is you can decrease this maximum path exposure. This is going to reduce the exposure in some certain areas of your scene and then get rid of these pixelated bright spots. Okay. If I bring this number down to, let's say, 1 and give it some time to calculate the lighting, you can now see that we no longer have that cluster of white bright spots on this asset. We still have some pixelated spots in here as well, but for that we can bring this number down even further. But I don't generally like to go below 1 because that also affects your exposure as well. So the best practice in here is to simply just reduce the maximum path exposure to 1. And if you still have some sort of fireflies in your scene, then you're going to have to adjust the roughness or metallic value of your asset. Okay. For example, you can see that we still have these fireflies in here, even with the maximum path exposure of 1. So in this case, I'm going to have to go into the material properties of this asset and, increase the contrast, maybe decrease the metallic value as well, so that we have a very diffuse sort of lighting here. Okay. So that is how you can get rid of all of these noisy pixelated bright spots in the scene. They are mostly common in metallic or shiny surfaces, and you're gonna most likely see them on these Minerva assets. Okay, I don't think you're gonna be able to see them on the surface or in the mountains or cliffs in the background. We're only gonna have these fireflies in the Minerva assets and maybe some other shiny objects as well if we have them in our scene. For now, I'm just gonna keep this at default. When we'll move on to the rendering section, then we'll deal with this max path exposure. Okay. So next up in here, we have a reference depth of field. If I split this window and enlarge this one, let me move just about there and maybe move, I don't know, somewhere around here, I guess. Maybe somewhere around here. Okay. Yeah, just about there. And if I move this window down here, I'm going to change this to path tracing, and let's give it some time to render the scene. Okay, I'm going to now take a screenshot of this window before and after I enable the depth of field. Let's take a screenshot, and now I'm going to enable the reference depth of field. And once the noise is all cleared up, I'll take another screenshot so that I can show you the difference. Okay, so the rendering is complete. Let's take another screenshot and let me show you the difference before and after I enable the reference depth of field. So this is the screenshot that I took before enabling the reference depth of field. In here you can see that around the edges of the arm of this character, we have this transparent sort of layer in here, some sort of jagged layer, which looks transparent, but it looks like there is something wrapped around his arm. Okay, we can see the same thing in here as well. We have this very transparent sort of layer around the edges of his hand. Okay, but if I open the screenshot that I took after enabling reference depth of field, you can see that in here the reference depth of field is checked. And if I look in here, you can see that I no longer have that weird transparent looking layer around the edges of this arm. Okay, same is the case with these hands as well. If I open the previous image, you can see that we have the similar effect in here as well with the antenna on his head. We have the same problem in here around his helmet and around the weapon as well. Okay, but after enabling reference depth of field, you can see that now we no longer have that sort of problem in here. Okay, so this is how a reference depth of field improves the depth of field that you have in your shot when you're using path tracing. So it's always a good practice to enable reference depth of field so that you have the maximum possible quality in your renders. Okay, let's now go back into Unreal, and next up in here we have a reference atmosphere. If I split this window and enlarge this window, and just hide this night scene and enable the environment lights, or in other words enable the day scene, you can see that in here we don't have anything below the horizon. But if I check this box, of course I cannot check this box in here. I'm gonna have to do that in the post-process volume of the day scene. Sorry, this is the night scene. I'm gonna set the post-process volume, and in here if I check this box, reference atmosphere, now you can see that we have this atmosphere below the horizon as well. Okay, it looks pretty weird, but of course we're going to work on that later on. But for now, that is all you need to know. Let's disable this thing here, disable this one as well, and I'm going to hide the environment lights as well. And let's enable the night scene that we have for path tracing. I'm going to just select the post-process volume, and the final setting that we have in here is the denoiser. Now the job of the denoiser is to actually get rid of all the noise that you have in your scene after completing the number of samples. Okay, let's say that if you have 10 number of samples in here, and if I enable the denoiser, you can see that even with the 10 number of samples, we don't have any sort of noise in the scene. Okay, and that is the magic of denoiser. If I uncheck this box, you can see that we have this huge amount of noise in the scene. But if I check this box, it's gonna just remove all the noise that we have in our scene. But you can see that after enabling denoiser, yes, it does get rid of all of the noise that we have in the scene, but our scene looks absolutely terrible. You can see that we have this very blurry sort of results in here, and it looks absolutely horrible. Okay, so the denoiser not only gets rid of all the noise that you have in your scene, but it also destroys all the detail as well. Even with a very high sample count such as 1024, after completing the number of samples, when the denoiser will kick in, we're not going to have very good looking results. Okay. Another problem with denoiser is that whenever you render your scene by using denoiser, it denoises each frame separately, and then you end up with very blurry or splotchy looking sort of results in your renders. Okay. I never use denoiser. It is always a good practice to increase the number of samples to maybe 2048, or maybe set this to an even higher number to get rid of all of the noise that you have in the scene. But using denoiser to get rid of all of the noise that you have in your shot or in your scene is not a very good idea. Okay. So these were a few settings for path tracing, and that's pretty much it for this lesson. In the next lesson, we'll have some more discussion about the path tracing global illumination. So I'll see you guys in the next one.